Thank you, Stephen. So far, we don't have any questions no questions have been sent in, although we certainly encourage folks to do that. We have 10 minutes set aside until 1:30 for questions for Stephen and team. One question I can ask in the interim, perhaps while we wait for any other additional folks to send in questions, Stephen, would be with the batch deposition. For folks who are interested in doing that, is that sort of, do they have to undergo any sort of like special procedures to initiate that? I was wondering if you could comment on the logistics or how that works.
Anybody who so we have a lower limit of 10 structures for accessing group dep. The amount of work that's required in terms of scripting to get all the files ready makes it unlikely that it's going to pay off for you unless you've got at least 10 structures to deposit in a single group. Anybody who does is encouraged to contact Jasmine Young. That's jasmine.young, Y-O-U-N-G, at rcsb.org. Jasmine is our chief biocurator, and she will work with the depositor to enable the group deposition process. Eventually, they'll be dealing with Chenghua Xiao, whose name is here. Chenghua is the person who actually does all the validation of the groups and has been very helpful to our contributors by providing them with guidance regarding setting up of the input files for group dep. So right now our threshold is 10 structures. That may change, but at the moment it's 10, and my expectation in the longer term is that software like Phoenix and others will create scripts within the structure refinement packages that will generate files that will actually be ready for group dep, and that may allow us to change the threshold slightly. But right now there's a fair bit of coding to be done, so 10 seems to be a sensible number. We've been, as you saw in one of the previous slides, I can just jump. Let me just find it. We just go back to the group dep slide for a moment. We've been working with teams at Roche, Merck, Serono, BMS. We recently received more than 800 depositions in 4 groups from the Structural Genomics Consortium, and also received 300 plus depositions from our first academic user, who was operating out of a lab in somewhere in Germany. I'm afraid the location escapes me at the moment. But this is the only sensible alternative to having to go through the OneDep system 30 or 40 times to submit an entire SAR series, which would become extremely onerous.
Okay, thanks, Stephen. We actually had a couple questions come in the interim.
Okay.
One question is in regard to the bromine cleavage, or the bromine leaving. Where did it go? As the bromide nearby, bromine radical, is it a bromine nearby? Is it a bromine radical? Is it reactive? What about the ligand? What is left behind? Is there any rearrangement?
So we don't. So we saw this empirically at SGX Pharmaceuticals, where we were doing fragment screening with a significant number of fragments or scaffolds that had bromine atoms present as leaving groups to support Suzuki couplings and the formation of carbon-carbon bonds. We never systematically investigated what was happening, but we did see routinely loss of the bromine in the during the course of the X-ray experiment. My suspicion is that the bromide just goes out into the solvent channel of the crystal and disappears. In this case, of course, we're dealing with a buried ligand. I just don't think we have enough information, unfortunately, to answer that question.
Okay. And then one more question. We do have a few more minutes left. We can get to this. The question is as follows. Obviously, the ligand restraint files are key, and it sounds like you all had to develop a considerable amount of expertise in how to do these better, how to check for problems, etc. Is that something that is going to be made available to the general public? And what about how to automate the type of manual creation it sounds like you did, such as looking at potential alternate binding modes or ambiguous density, etc.?
Okay, that's a multi-part question. So let's start with the question of the restraints. I think this is an area of quite intense investigation, not only within the D3R team, but with other groups. Recently, there was publication of a quantum mechanical plug-in to Phoenix that we did some test calculations on recently, and discovered that piece of software is very much in its infancy and not yet ready for production. I think things will get better in the near term as we improve the validation system for ligands in the PDB. Some of you may remember that we, meaning the Worldwide Protein Data Bank, the Cambridge Crystallographic Data Center, and D3R, co-sponsored a workshop back in 2015 looking at ligand quality in the PDB, and we made a series of recommendations as to how ligand validation should be improved. And we're currently, the WWPDB 1DEP team is currently in the process of doing the software engineering necessary to improve the validation with reference to the values extracted from the Cambridge structural database using Mogul.
Yeah, okay, sorry.
Yeah, go ahead.
Oh, yeah, I was just going to say, maybe you were about to say this, that tell everybody working on essentially a detailed methods description of how the protocol we eventually arrived at. So that'll be made available.
That'll be made available, and as with all of the software that we develop here within the RCSB PDB, once it's sufficiently robust, we will of course be making it available to the community. Some of this will be made available at the level of the deposition system. Some of it will be made available at the level of our website, rcsb.org. And I urge you just to watch the space. It's it's a source of some embarrassment to me as to how poor, on average, ligand structures are in the PDB versus the protein structures. And this is something that we're working hard to remedy within the WWPDB partnership. The next iteration of the validation software will be a lot better at flagging outliers with reference to the Mogul software and the CSD. And I think that will go a long way to improving the quality of the geometry of ligands in the PDB in terms of new entries. It will also effectively we hope, do away with the publication of twilight zone ligands where there's not adequate electron density to actually support the interpretation, because these will become very obvious in the validation report, which is now being required by many journals for publication of a co-crystal structure.
Okay, very good.
I'll stop there. Yeah.
Thank you so much, Stephen. That was terrific. We're just
Great.
now.
I'm going to log off now, and I'm going to go upstairs and join Wang and Chenghua in the viewing room.
Sounds great. Thank you again.
Thank you.
Bye.